Assalamualaikum and hello everyone. My name is Nur Aleeya Nasuha binti Azrul Affendi and I'm from class Math 2. Today I'm going to present about learning theory in subject curriculum studies and learning theories in primary mathematics. For the first theory, Burners learning theory. Now I'm going to explain about Burners learning theory. Burners theory revolves around three main ideas. For the first one is enactive, iconic, and symbolic representation. These stages describe how children develop understanding and process information as they grow. So for the first one, which is enactive representation, it is a learning occurs through actions and physical interactions with objects. For example, young children learn by touching, manipulating, or moving objects. Now we go to the second one, which is iconic representation, which is a learning is based on visual or mental images. Children begin to use pictures, diagrams, or visual aids to understand concepts. And for the last one, which is symbolic representation, it is a learning involves abstract thinking using symbols, language, and mathematical notation. At this stage, children can reason logically and solve problems without relying on concrete objects. Now we go to application of learning theories and constructivism in mathematics activities. So for the first one, on inactive stage, we're going to use physical objects such as blocks, counters to help students understand basic math concepts like addition or subtraction. And for the second one, which is the iconic stage, it will introduce visual aids like graphs, diagrams, or number lines to represent mathematical ideas. And for the third one is symbolic stage. This is a transition to abstract symbols such as numbers, equations, so students become more comfortable with the concept. Now we go to example of activities that we can do in inactive stage. For the first one, it is a counting with manipulatives. It is an activity of using physical objects like blocks, beads, or buttons for counting, addition, and subtraction. The objective of this activity is that students physically group and move objects to solve the problems. Here, it involves scaffolding, which is start with small numbers and gradually increase complexity.
You can help a child learn about adding by using any small objects, like buttons. For example, you can place two buttons in front of the child and ask, "How many buttons are there?" The child can count them and say, "2." Then you can add 3 more and say, "If we get 3 more buttons, how many are there now?" The child can count them again and say, 5. And you could say, "That's right, when we have 2 and add 3 more, we have 5. This activity will help a child start to understand basic addition.
Another activity that we can do is building shapes with straws and Play-Doh. This activity uses straws and Play-Doh to create 3D shapes. This activity objective is students learn about geometric properties such as sides, vertices, and edges. So here, scaffolding happens with start with simple shapes, which is triangles, squares, then we move to the more complex shapes such as cubes and pyramids. Now we move to the example of activity that we can do in iconic stage. So for the first one is matching games. This activity is create a matching game where children pair pictures with corresponding words. This activity objective is that children develop visual recognition and vocabulary. So the materials used are picture cards or we can do by online quiz. And for the last stage, which is symbolic stage, the activity that we can play is fraction and decimal games activity, which students play games that involve converting fractions to decimals and vice versa. This such as matching cards with equivalent fractions and decimals. This activity objective is that children understand the abstract relationship between fractions and decimals. And the materials used in this activity is fraction and decimal cards. Another application of learning theories and constructivism in mathematics activities are encouraging discovery learning. It is by allowing students to explore and discover mathematical concepts on their own, fostering curiosity and deeper understanding. And for such exploratory activities that we can do is by puzzles, game, or investigations to engage students in mathematical thinking. And for the second one is integration with technology. So for the application is by using digital tools to enhance learning and provide interactive experience. So for example that we can use is by using math apps such as Desmos, Khan Academy or Prodigy to practice skills and visualize concepts. Now we move to implications of cognitive learning theories and constructivism in teaching mathematics. The first one is active learning and discovery. So the implication is students learn best when they actively construct knowledge through exploration and discovery rather than passively receiving information. So the strategies that we can use is by using hands-on activities to allow students to explore mathematical concepts and encourage them to problem solving and inquiry-based learning where students discover mathematical principles on their own. The second one is collaborative learning. The implication is learning is a social process, and students benefit from working together to solve problems. The strategies that we can use group work and peer teaching to allow students to learn from each other. And the second one is assign collaborative projects where students must work together to solve complex problems. And the third one is facilitate discussions where students share their ideas and strategies. And the last one is building on prior knowledge. The implication is new learning is built on what students already know. So teachers must activate and connect to prior knowledge. So the strategies that teachers can use is begin lessons with a KWL chart. What I know, what I want to know, what I learned to assess prior knowledge. Use pre-assessments to identify gaps and tailor instruction accordingly. Next, we go to implication of cognitive learning theories and constructivism based on individual. The first one is personalized learning path. The implication here is that each student has a unique way of learning and instruction should be tailored to their individual needs and pace. The strategies that we can use is by using diagnostic assessment to identify each student's strengths, weaknesses, and their prior knowledge. And the second one is encouraging a growth mindset. The implication is that individual learners benefit from believing that their abilities can improve with effort and practice. So the strategies that we can use is by praise effort and strategies rather than innate ability. The second one is by normalizing mistakes as part of the learning process. And the third one is supporting emotional and social needs. The implication here is that individual learners have unique emotional and social needs that impact their ability to learn. So the strategies that we can use is by creating a supportive environment where students feel safe to take risks. And the second one is by provide positive encouragement to gain confidence. Second theory is Piaget's cognitive learning theories. Now we're gonna go through Piaget's cognitive learning theories. I'm gonna explain about Piaget's stages of cognitive development. Piaget's cognitive development theory emphasizes how children construct knowledge through active learning. John Piaget's theory of cognitive development suggests that children move through four different stages of learning. The first one is sensory motor stage, which is during birth to 2 years. And the second one is pre-operational stage, which is between age 2 to 7. And the third one is concrete operational stage, which is between 7 to 11 years. And the last one is formal operational stage, which is between age of 12 and up. So let me explain in detail four stages of cognitive development. For the first one, sensory motor stage, which is happened during 0 to 2 years. The characteristic here is infants learn through sensory experiences and motor actions. They develop object permanence, which is understanding that objects exist even when out of sight. And the second one is pre-operational stage, which happened between 2 to 7 years. The characteristics is children develop language and symbolic thinking. They are egocentric, which is they struggle to see things from others' perspective. And the third stage is concrete operational stage, which happen between 7 to 11 years. The characteristics are children begin to think logically about concrete objects and events. They understand conservation, classification, and seriation, which is ordering objects by size and weight. And the last stage is formal operational stage, which happen 11 and up above. Characteristics here is adolescent develop abstract thinking, hypothetical reasoning, and problem-solving skills. They can think about possibilities, moral dilemmas, and future outcomes. Now we move to application of Piaget's learning theory in mathematics activities. For the first stage, which is sensory motor stage, we can do shape sorting. This by providing different geometric shapes such as circles, squares, and triangles. So we let children touch, feel, and match shapes to corresponding slots. The learning outcome by this activity is that they develop sensory learning and object permanence. For the second stage, which is pre-operational stage, which we can do is by counting with objects. This is by using colorful beads or blocks to teach counting. For example, let's count 4 apples. So then we can use 4 beads and we can customize it on the tree. So the learning outcome from this activity is that they can support symbolic thinking and early number recognition. And for the third stage, which is concrete operational stage, we can do by fraction pizza. This is by using paper cutouts of pizzas that divided into halves, thirds, or fourths, as we can see in the picture given. So the learning outcome from this activity is that we can encourage hands-on learning of fractions. And for the last stage, which is formal operational stage, we can do algebra puzzle challenge. As you can see from the picture, you can see that the question give a lot of pictures of apples, bananas, and watermelons. So this will have students to solve to find the x and explain their reasoning. So the learning outcome from this activity is that they develops algebraic reasoning. So now we move to implications of cognitive learning theories and constructivism in teaching mathematics. For the first one is active learning through exploration by using hands-on manipulatives like blocks, counters, and geometric shapes. This encourages students to explore mathematical patterns rather than memorizing formulas. This will allow trial and error to promote independent problem solving. For the second implication is by constructing knowledge instead of rote memorization. This pose open-ended questions that require students to think critically. They will use real-world applications to make math meaningful, and this will encourage self-discovery rather than providing direct answers. And the last implication is supporting individual differences in learning. This by providing differentiated instruction to match students' cognitive abilities. This will allow students to work at their own pace in solving mathematical problems. They will use peer collaboration to help students learn from each other. And last but not least, let's move on to implication of cognitive learning theories and constructivism based on individual. So for the first one, knowledge is constructed, not transferred. Learning does not happen by passively receiving information. Instead, individuals actively construct knowledge based on their interactions with the environment. This means that teaching should encourage exploration, questioning, and hands-on activities. For the second one is cognitive development influences learning. Piaget emphasized that cognitive growth happens naturally as individuals interact with their surroundings. Learning should be age appropriate and match an individual's cognitive abilities. And for the last one is learning requires active engagement. People learn best when they are actively involved in the learning process rather than being passive listeners. Activities like problem solving, experiments, and real life application enhance them. And that's all from me. Thank you. Bye bye.